ladies and gentlemen, we are talking today about finding special products of polynomials. So it's the same thing where we're multiplying, but there's quicker ways to do it. So if they look like something, we know it's a special product, and we can just stick it in a quick formula and we're done. Okay? So we know a polynomial is a monomial or sum of monomials, each called the term of the polynomial. A polynomial with two terms is a binomial. A polynomial with three terms is called a trinomial. And we're going to talk about these different things. First, we're talking about sum and difference pattern, which is already right here on your paper. Sum and difference pattern. Okay? A plus b times a minus b is going to give you a squared minus b squared. And then right here is the difference of two squares. This is the sum and difference pattern. This is the difference pattern. And this is the sum of two squares. Let's make sure that I believe they use different words in your book. Make sure they're right. Okay. So we get the sum and different patterns and squares of a binomial pattern. So this is sum and difference. Right here. And these two are squares of binomials. Okay. Some of your questions are going to be in your homework. Is it a square of binomials? Is it a sum and difference? And you have to be able to say yes or no. Okay? The way this works is if you've got a plus b times a minus b, you're going to get a squared minus b squared. You don't have to FOIL. You don't have to use the table method. You can just know. Your sum and difference, your squares of binomials, if you've got an a plus b squared, it's just a squared plus 2ab plus b squared. If it's a minus b squared, it's a squared minus 2ab plus b squared. And I'm going to show you how some of these work. We're going to go to example 1. Use the square of a binomial pattern and find the product. So we've got 3x plus 4 squared. Okay, so first I have to figure out which one of these special squares it is. Does it look like a plus b squared, a minus b squared, a plus b times a minus b? Which one does it look like? The first one. Okay, so I know that I'm going to take this right here, that's my a, this right here, that's my b, and I'm plugging it into a squared plus 2ab plus b squared. Okay, what's 3x squared? 3x, the whole thing squared, is what? 3 times 3 is? So we have 9x squared plus, what's 3 times 4? 12. What's 12 times 2? 24x plus, what is 4 squared? 16. So these are just special products. Okay, special binomials. Let's try another one. We've got 5x minus 2y squared. Does it look like the first one, the second one, or the third one? Is it a plus b squared, a minus b squared, or a plus b times a minus b? A minus b squared. Okay? So now I'm going to look, and I'm going to say to myself, okay, this is a. This whole thing right here is b, and I'm going to plug it in to a squared minus 2ab plus b squared. What's 5x, the whole thing squared? 5 times 5 is? So we get 25x squared minus 5 times negative 2 is 10. 10 times 2 is 20. So negative 20xy. What is negative, the whole thing, negative 2y squared? What's negative 2 times negative 2? 4, positive 4. What's y times y? Y squared. See how the pattern's easier? Why don't we try one on our own? But it's not on here, I'll make it up. We'll try one on our own. Okay, let's look at 2x plus 3, the whole thing squared. So I want you to try this one on your own. Amaj, sit up, please. Well, it's not going to take it from me. Let's try this one on our own. It's not on your paper. You need to write it down somewhere. 2x plus 3 squared. 2x plus 3 squared. Try this one on your own. It's not on your paper. First, you're going to figure out which one it is. Is it a plus b squared? Is it a minus b squared? Are we doing a plus b times b, a minus b? Okay. Let's try Aaron. Which one is this? Is this an a plus b squared, an a minus b squared, or an a plus b times a minus b? Which one of these is the one that we're doing? A plus b squared. Okay, so it's the first one. So I know my answer is going to look like a squared plus 2ab plus b squared, where this is a and this is b. Okay, Elena, what is my first term going to be? If I'm squaring a and a is 2x, what do I get? It's 2x, the whole thing squared. What's 2 times 2? What's x times x? There you go. Okay. Shelby, this one's a little bit harder. You ready? What's 2x times 3? Okay, what's 6x times 2? 6 times 2 is, so it's 12x. Okay, Christian? What's 3 squared, Christian? What's 3 squared? 3 times 3 is? That's plus, 3 times. There you go. Plus 9. Okay, see how it's just a pattern? Let me be clear that if you go 2x plus 3 times 2x plus 3 and either FOIL or make a table, you get the same answer. This is just a quick way to do it. When we do factoring, you'll need to know this stuff. All right, let's do example 2. We've got t plus 5 times t minus 5. So is it a plus b squared, a minus b squared, a plus b times a minus b? Yeah, it's that last one. So I'm going to take this one, because it's a, and I'm going to write t squared. This one is b, so I'm going to write minus 25. That's all you have to do. All right, Jalen. We're going to try this next one. All right, Jalen. So this is obviously the third one. A plus b times a minus b. What is my first term going to be? What is that going to be? What is my, see how this is t times t, so I get t squared? What would it be here? Which is? What do they have next to them though? How many x's are there? So it should be. Okay, Justin. What do I write next? Minus, good. And what comes after the minus? Perfect. I I really like this last one because it's so simple. You square the first one, square the last one, you're done. Okay? All right. Okay, you guys probably have seen Punnett squares before. Okay, stop doing that. You've probably seen Punnett squares before in your science classes. If we've got two border collies that we're breeding, one has the gene for black patches, one has the gene for red patches. Okay, so two border collies, one has a black and red gene, one has a black and red gene to make patches. Okay, the possibility of what their kids will look like is right here. So I got a black gene and a red gene, a black gene and a red gene. So I can come up with two black genes, I can come up with a black gene and a red gene, I can come up with a black gene and a red gene, or I can come up with two red genes. Now, if you have that big B, that black gene, the patches are going to be black no matter what. Okay, it's called a dominant gene. So, how many out of these four squares are going to have black patches? 3. So 3 out of 4 means how many percent? 75. So there's a 75% chance of black patches. Okay, we're going to try to figure out how this is going to look like polynomials. All right? So what we've got is B plus R squared. Right? We've got B squared, which is the same thing as B times B, plus how many BRs are there? 2 BRs, and how many RRs? 1. Okay? It's exactly like this pattern right here. And there will be a problem just like this on your homework. There will be a problem just like this on your homework. Okay. So remember, it'll say, is this a sum or a difference? You'll have to say yes or no. Is this a square of two polynomials? You have to say yes or no.